So let's go ahead and let's use our knowledge from the previous video with regards to quantum numbers, those solutions from the wave function. Let's use those rules to determine quantum numbers for particular orbitals, specifically for particular values of n, which is the principal quantum number. Let's use that to determine values for L, which is the angular quantum number. It's sometimes also called Azimuthal quantum number. Your online homework and MyTap uses angular momentum, but sometimes you'll also hear the word Azimuthal, mainly for me. They both mean the same thing. And from that angular quantum number, you can get the magnetic quantum number. So let's use the rules we talked about in the previous video to determine the values related back to the principal quantum number. So if I have a principal quantum number of 1 and n equal to 1, I know that my L values are supposed to start at 0 and go to n minus 1. So that means if my n is 1, then my only value for the angular momentum quantum number is 0 for n equals 1. When I go to 2, my possible values are 0 and 1, because remember, the angular quantum number is a range of values based upon n, specifically 0 to n minus 1. So that means that the values of L for 3 are 0, 1, and 2, and the values for 4 are 0, 1, 2, and 3. So that's how you determine your azimuthal quantum number or angular momentum quantum number for a particular quantum number. It's a range from 0 to n minus 1. The magnetic quantum numbers are related to the L value. So for every L value, there is a range of m sub L values from negative L to plus L. So if I have an L value of 0 for the n equals 1, my magnetic quantum values are just 0 because there's no negative 0. It's just 0. When I move on to the n of 2, I have two L values, 0 and 1. So if I was to list all of the m sub L values for those two L values, I would still do 0, so still the same one for n minus 1. But I also need to list the ones for L. And so when L is 1, which we do have a 1 here, my m sub L values are negative 1, 0, and plus 1. So remember that m sub L values are a range from negative L to plus L. So all of those would be the 0, negative 1, 0. Those would all be the m sub L values for both of those L values. Similarly, when we get to n is equal to 3, we have 3 L values to take care of, 0, 1, and 2. So my magnetic quantum values are going to be the same as for 0, 1, 1, but I'm also going to have ones associated with L equal to 2, specifically negative 2, negative 1, 0, 1, and 2. And then finally, when you get to n is equal to 4, we're going to have this, since we've got 4 L values, we need to have 4 ranges. So all of the m sub L values that we need to list are the same as for the previous quantum number, but we need to add the ones for L of 3, namely negative 3, negative 2, negative 1, 0, plus 1, plus 2, plus 3. So those are the rules for determining these 3 quantum numbers. We're going to talk in subsequent videos as to, okay, well, this is great. What exactly do all these numbers stand for and how are they useful? We will talk about that in actually the next video and in chapter 7. But you should feel comfortable using the rules for determining quantum numbers for your exam and for your online homework.